Welcome to the lesson on triangle midsegments. In this lesson, we will discuss some of the basics of triangle midsegments and how we can solve a variety of problems involving them. Now, a triangle midsegment bisects two sides of a triangle and is parallel to and half of the third side. So as you can see, we have a very basic, essential, and example of a triangle midsegment where BD is the midsegment. It bisects side AC and bisects side CE, and it's also parallel to the third side, AE. In addition, we know that BD is half of the length of AE, so BD is equal to half of AE. Now, every triangle can have more than just one midsegment. So let's say I estimate the the midpoint of AE and connect it to point D. I've now made another midsegment that is parallel to the side AC. So I've made another midsegment, meaning that I bisected AE. And let's go ahead and call this new midpoint on AE point F. So I've made new midsegment DF. Now I can make the third midsegment here by connecting F to B. And that midsegment BF will be parallel to the side CE, and BF will be half of CE. So the three midsegments all have a corresponding third side that they are parallel to and that they are half of. Midsegments do get very interesting when we talk about right-angled triangles, although the principles do remain the same. So here we have a hypotenuse, and let's estimate the midpoint of the hypotenuse and drop it down to the midpoint of one of the legs. Now this will bisect the hypotenuse, of course, and bisect the third side, and make this midsegment parallel to the third side, making that also perpendicular. As I find the second midsegment that bisects the third side, they are also perpendicular. So in a sense, my two midsegments here in this right triangle end up creating a rectangle as well as multiple sets of congruent smaller triangles. So now let's apply this by doing a few practice problems. In this problem, I know that DE is parallel to AB, and I'm told that I need to find the length of AB. So DE is that midsegment that I do not know the length of, and I don't know the length of AB either. That's my goal that I need to find. So I know that because they're parallel, I would guess it's a midsegment, which means it divides the other sides into 3 and 3, and CA would also be 4 and 4. These measurements would lead me to believe that this is a right angle triangle, so I can use that 3 and 4 to go ahead and find the length of DE by the use of the Pythagorean theorem. So 25 is equal to DE squared, and by square rooting both sides, I get that DE is equal to 5. So if DE, my midsegment, is equal to 5, then my larger third side must be its double, so AB is going to be equal to 10. Now let's apply some of these principles to perhaps do an informal proof where I have to find the measure of angle MPB. In particular, I'm wondering if it is a right angle triangle. Now, because I know this line has bisected two of those sides, it would lead me to believe that the line LP is parallel to AB. And because it's parallel all the way through, that means that this line PB acts like a transversal that is crossing over parallel lines. And because those lines are parallel, these two angles must both be the same and they must both be right angles because they are corresponding angles in this set of parallel lines.